Hello everyone, welcome once again to another Power BI data analysis tutorial by Slides. In this part, we are trying to analyze the very famous wine quality dataset. This dataset is downloaded from UCI.edu website. This particular dataset is used in variety of regression and classification related analysis tasks, and here you can see effect of different physiochemical attributes on the wine quality. So wine quality variable is the output variable here, and we have simply used these two images. On the basis of these two images you can apply filters. This is red wine, this is white wine, and you can see different parameters, different attributes changing their effect on the overall wine quality. So for example, average quality by alcohol percentage, alcohol quality by chloride, citric acid versus quality, etc. And you will learn how to create a dashboard like this, how to use or apply this kind of image based filters. Everything will be taught in this tutorial. So let's get started with it. So let's learn about the dataset and its preparation for analysis. This dataset is known as Wine Quality Dataset, which has red and white wine samples from the north of Portugal, and the goal is to model wine quality based on physiochemical test. In the dataset, you will find these type of variables like fixed acidity, volatile acidity, citric acid, residual sugar. All of these have role which is feature. These are all continuous numerical values like pH and sulfates, and then you have alcohol, color and quality also. So this dataset can be downloaded from UCI.edu website. When you will download the dataset, you will receive a zip file. In the zip file there will be two CSV files. First file is wine quality white. So this particular dataset has all the data information, data samples of white wine. Here you can see we have fixed acidity, volatile acidity, citric acid. These are all numerical features as I explained you earlier. And quality is the target variable. This quality value is from 3 to 9. So lowest quality wine has a quality of 3, highest quality wine has a quality of 9, and it is based on these different elements. It's different physiochemical test or based on physiochemical properties, right? And what I have done here, I have added an extra column here called color. So because this is wine quality white, so I have just added color as white here, and this is wine quality red. We have less samples of wine quality red. We have around 1600 samples of this, and here I have added color red. Okay, now this is our data set. What we can do, we can simply make a union of these two tables, and that will give us a big data set. To make union of them or to append the queries, first we will open Power BI. In Power BI we will load any one of them. So because the files are given in a CSV format, so we will use text CSV connector here. From here I will go into the file and connect any one of them. After connecting one of them, I will go to transform data. So it will open Power Query Editor, and here you can see all the columns are matched with their values properly. Here I am going to do one more thing, and here I will write what new source text CSV, and now this time I will load red. So now I will have two tables, one for red wine and one for white wine. We can also start analysis in this way, but what we are going to do, we'll click on one of them, and from uh, here append queries, we will use append queries as new, and we have two tables. So first table will be wine quality white, second table will be wine quality red, and this will be our wine data. Okay, and now in the data we will see fixed acidity, volatile acidity, etc. In the color you will see for all white quantity values we have white written, and it is showing list may be incomplete. Let's see. So after clicking load more, you can see red and white, right? And now this is our final table. We will simply close and apply. We can remove other two tables because this is the final table that we are going to keep. So we can remove it from the model, and we will remove this also from the model. So now we are left with the final wine quality data. In order to check and make our conclusion that we have done it correctly, we will just add a donut chart here, and in the donut chart we will add color. So you can see red and white, and we also have to see if we have number of rows. So obviously we don't have total number of rows here, so we will go to modeling tab, create a new measure and call it num rows, and here we will call it count rows. In count rows we will use the name of table, that is wine table, and after using table name we will just create. Once the total number of rows are created, we will simply drag it in values, and this shows that we have around 4898 samples of white wine and 1599 samples of red wine. So from the data set also we can see 4899, and so this is correct, and we can simply give this donut chart a title. This is color wise samples. Okay, so we will go to title and we'll write color wise samples count, and here in title itself we will simply arrange it to center, make the heading bold, increase its size a little bit, reduce the overall size, and as I do in most of my tutorials, I go to effect, enable shadow and a visual border, and select a border that represent our theme now. And we can go to visual, and in slices we can try to select particular colors for them. So for white wine this color is used often, so we will use this color, and for red wine, so for red wine this color is used. Okay, if you want you can make it a little light obviously, but I have simply copied the hexadecimal codes. So this is color wise samples of red and white wine. We can also go to text box and create a text box. This is wine quality analysis, and we will simply reposition the text box on top, and we will just increase its size to 28 and maybe 32, and invert the color. So let's use this color as an invert, and in the background we will use the wine color. This is wine quality analysis. Again, you can use any other choice of colors, but I am just using the same color theme. In effects, we will just enable the shadow here. So this is wine quality analysis. Now we will try to see effect of different type of variables on the quality. So the idea is to see, because these are all features, these are all numerical continuous variables. So the idea is to see the effect, like if fixed acidity increases, does it also increase uh, the quality? So for that, the type of chart that we can use for two numerical values is scatter chart. Obviously, the wine quality range is between 3 to 9. Okay, so that we have to check. But what I'm going to do, I will just use a scatter plot here. In a scatter plot, I will put alcohol on the x-axis and wine quality on the y-axis. Okay, so from here we have quality on the y-axis, which is our output, and by default it will make it sum of alcohol versus sum of quantity or quality. We will use don't summarize this and don't summarize this. So you can see for different type of alcohol values, our y-axis values are also there. So that's why when quality is increasing, we have different sort of samples here. And a reason is the data is more like a discrete value, the quality that we are getting, the output that we are getting, not a continuous value with a wide range. So what we are doing here, we are just using a clustered bar chart. In clustered bar chart, we have different ranges of alcohol on the y-axis. So you can see 3, 4, 5, 6, 7, 8, 9, the different qualities that we have. Wines with total different qualities, and this is sum of alcohol, like the total value of all the alcohol fields combined, but we will just use average here. So on the basis of average value of alcohol here, alcohol 9.5, 9.4. So in UCI Wine Quality Dataset, alcohol refers to the alcohol content in wine, which is a critical physicochemical property, and it is typically expressed as a percentage by volume and represents the concentration of ethanol in wine. So here the ranges can be between 8 to 14% in the dataset. So when you will go to dataset, you can see 8% is the lowest value and 14.9 is the highest value. So here we can see average of alcohol by quality. So average percentage, and you can see quality 9 has the highest average percentage, and average percentage, then there is a linear, you can say, decrement here, like in quality 8 11.6, in quality 7 11.39, in quality 6 10.5, but here you can see in quality 3 and 4 they are also good. So it's like low average alcohol quantity wines are also good, and very high are also good, but quantities where quality is 5 and average of alcohol is 9.84 shows that if you compare them with other type of wines, then this quality is slightly on the lower side. But one thing is for sure, that when you are trying to create a model that can predict the quality of a wine on the basis of different input parameters, in such cases, this particular variable, alcohol percent, obviously has a great role to play. And we will simply copy its style, like format painter, and here we will simply use the same sort of colors. And before applying any color, we also have to see color wise samples. So we have like white and red wine. So here in legend we can also bring the colors. So we can simply bring the color here, and then we will see color wise data. So in case of red wine, we don't have any samples with average of 9. Like for quality of 9, we don't have any samples in red. But in case of red, for quality 8, you can see average value. So this is average of alcohol 12.09, red, quality 8, right? So here the average is more, and Here the average for quality 8 is less, but this is also a simple explanation. Now we used clustered bar chart. We can also use a stack bar chart for this purpose to see its effect, or even a stacked column chart. And I will simply change the title a little bit. Average of alcohol. I will make it shorter. Average alcohol by quality. Color is something that we are just using to recognize. This is average alcohol by quality. We will later use different type of wines as filter also. Now I also have color and image. I also have this simple Excel file where I have used two images, one for red wine and one for white wine. So this particular Excel file has two URLs. These are images. So what we are going to do, we are also going to introduce that new data set, and we will create a simple model because our color here is same as the column that we used there. So color column will be used to join them. So we will get data, that's an Excel file. We will use images.xlsx file, and when I will select this, it will show me that column 1, column 2 are not mapped properly. So I will transform the data. When we are transforming the data, we will simply click on this table icon here and say use first row as header. Now it is correct, and we will simply close and apply. Now we have this here. Let's check the model view. So in model view, it will automatically be joined because we have used the same name, color. Now we have this data. Why have we created and how can we show those images? So you can either use a matrix view or a table view. This is one option. In your matrix view, we can bring, we have rows and columns. Okay. So from images table, we will bring color and images. And before bringing that, we have to tell Python that that is actually an image URL. So you have to go in table view, and in table view, click on image, go to the image column. You can see currently Power BI is recognizing it as a text value, and data category is uncategorized. So we will say it's a image URL. Okay. Now Power BI understands it's a image. We will just press Ctrl S to make these changes. So after making the changes, we once again go to report view, and here we will try to use color in columns and image in rows. Let's see if we are able to see the data. You can see we are able to see the images. Okay, and on the basis of images, the data is getting filtered also. So we will simply get rid of the column, and here we will reposition it. If you want, you can increase its size also. So here go to properties of this particular matrix chart, properties of the visual, where you have image size. I will use image of at least 125 pixel so that we can at least see what image we are choosing. So this is image. Okay, its title is also given as image here. So in the visual, here you can see column header is given. We can increase or decrease its size, make it bold, telling like image. Obviously it is showing image. We'll see what we have to do there. So this is image, and text alignment also, title alignment and text alignment we will keep in center. And in format visual, we will simply rename for this visual as wine. Okay, so now you have this image, and we also have border here in properties. Let's say if we want to make the border white. Okay, so here we will select any one of them and data will get filtered. So this is just a simple type of filter that we are going to use here. And for this entire matrix or matrix chart that we have, we will enable a simple shadow so that we have the same style, and, and a complete border with some color that represents our theme. Okay, this is a simple example that you can use for filters. Otherwise, you can use the conventional filters also. If you want to reposition it, you can reposition it on top here. So, for example, we can shift it here. It's totally your choice, but whatever space you want to use, you can utilize. Now, let's move ahead and see effect of chlorides also. So, first of all, we'll go back to our tables. In tables, you see this is also physicochemical property, and for chlorides also, we will just use a stacked column chart here, and or what we can do, we can simply create a copy of this, Control V, and here we will remove average of alcohol from here, and we will use sum of chlorides, right, for different ranges. So you will also see for different quality what is sum of chlorides for different type of wines. But here we will bring quality. Let's try to change the axis, and you will see a different type of value. Okay. Now you can see when we have put chlorides on the x-axis, because it's something that will affect the quality of wine, right? So here you can see on the basis of the different values of chlorides that we have, that for white wine the average value starts at around 0.01 mark and goes up to approximately 0.06 mark. For red wine it starts at around 0.04 mark and goes up to 0.13. So you can see in different type of wines what is the quality of wine here, what is the percentage of fluorides there, and this is something that obviously we can use a filter here also. So we can see most of the values are in this range, right? Because we are adding the chloride. For different chloride range, you can see we have some of quality. So we can also say use average of quality. Data will be different, but it will represent almost the same kind of thing. But here, when we use average of quality, it will show us average for each chloride value, right? So what we have to do here, when we have this type of continuous numerical values, we can simply create a group. So you can click on these three dots, create a group, and currently you have values from 009 minimum value to 2.61 maximum value. Here number of bins is 38, right? We will say we want number of bins to be 15. Like we are grouping all these samples into bin sizes of 15, right? Total 15 bins. So now one bin size becomes 0.04. Okay. And when we will click OK, so instead of chlorides, we will use bins here. So now you will have 15 different bins here, and for 15 different bins you will see the distribution of red and white wine. You will see for chlorides value of more than 0.33, all the type of wines are red wine only, and for values less than this we have mixed values. In the range of 0.3, 0.29, which is the chloride value, the average quality is 4.5, and that is only white wine. Okay, average of quality is mostly the same in all the cases, but here on the basis of this we can say in chlorides, in different chloride values, what is the possibility of different type of wine here, and we can say this average quality, this is kind of affecting the average quality, so we can keep this particular variable. If you want to simply simplify it for one particular type of wine, you can obviously select the filter and see it in action. And we will simply change the title to average quality by chloride. And in this case also we have to do the opposite, because on the basis of alcohol quality will either increase or decrease, so we have to do it like that. Here also you will see the same type of data, so every time we will simply go create a group and we will say we want 10 or 12 groups, so number of bins, and we will reduce 38 by 12 here, so we will have the data and we will just use this variable here. So now here also you can see we are almost getting the same type of value, but we can see when alcohol percentage is increasing for red wine, you can see average quality also getting increased, same for the white wine. In case of red wine, for alcohol value of around 14.33 or more, we only have the red wine samples. Yes, quality, average quality is less here, but alcohol value is more. So you can see best uh, alcohol percentage according to this data for red wine is around 13.75 mark. Okay. For this type of chart we have used a stacked column, but we can also use cluster column to see them individually, right? So for example here now we are seeing almost the same data, but you can see uh, them individually. So whatever you want to use, you can use. So I will leave them both here. It's your choice. Always remember the individual value, the value on which the output is dependent. That if you use on y-axis is always a good choice, because on x-axis we put independent value, on y-axis we mostly put the dependent value, and hence its heading will also get a little bit changed. This is actually average quality by alcohol percentage. Now there is one more thing here. For example, this variable here is given as a number. So using the table view, if you go here and you know that it's a percentage, so you can also use the percentage sign. Okay, so it will be represented in form of percent, but we will not use it right now. We will simply leave it as it is, but if you want you can use it as a percentage also. Over your data bars, if you want to show the value, so you have to enable the data labels. Okay, just enable the data labels and you will be able to see the values also. You can enable or disable data value size here in order to show like your value size, if you will reduce or increase, and when you will zoom it you will definitely see those values, because uh, our chart sizes are so small. That's why in some cases we are not seeing the values, but this is how you can enable or disable a data value, right? Now similarly as we are doing, so we can also use how citric acid value correlate with wine quality. Obviously the quality is also a number, but we may not get the best value here, but how they correlate with each other. So we will just show one more case here. In citric acid, we'll put on x-axis, like if we are increasing or decreasing the value of citric acid or citric acid, will it increase or decrease the quality. So here we will use don't summarize. So you can see what different values of citric acid, what is sum of quality. We can also say what is average quality, and we can say don't summarize to see the different samples. Here you can see quality, for quality 6 we what citric acid value is, for quality 5 what is the range of citric acid, for quality 9 what is the range of citric acid. So this is something that you can see here. And what we can simply do in case of legend, we can also include the color here as we are doing so far. And here you will see for different values, right? What I'm just going to do, I will select this and use format printer to copy the same style. So that you can see the same kind of styling. Most of the values are overlapping. In case of red wine, we have one sample here where citric acid value is 1.0 and quality is 4. Okay, so here you can see in for quality 6, in one case when citric acid value is highest, then quality is 6. So this way, for different citric acid range, you can see different values of uh, different quality of wines. We will simply call it citric acid versus quality. Similarly, we can copy this, and here we have used density. We will use don't summarize. So we can see for different density values. Here you can see density value starts from 0.98 and goes up to around 1.03. And here we will simply go to title and call it density versus quality, because for finding correlation, these two are the different type of charts that we can use here. If we have to see it as a column chart here, then we can simply create these groups, the grouped columns. Otherwise, we can simply use these scatter charts. And here also you can see on the basis of density, you can see when density kind of is lower, then the quality is kind of higher. We can say that like upper ranges of quality, density is lower than what is it in the case of lower values. So this is also causing a little bit of effect on our output variable here. Now after copying average quality by alcohol, we have also used a simple chart here, average quality by fixed acidity. So I simply created a group here for fixed acidity. I have used number of bins as 12, same as above. And here we can see this is average quality by fixed acidity value. And here also you can see for some acidity values or for some different bins that we have created. For example, here we have fixed acidity bin of 11.87 or 12.88. So here we only have red wine samples and average value or average quality is around 6 here. So we can see that the range is varying on different values of fixed acidity, and the variance is more in case of white wine here. Okay, so this is also an important parameter that will help us in finding out these values. So this is average quality by fixed acidity. Now let's see if right now we have used effect of only one variable on our output variable, and we have just used two different type of wines as a legend here, as a hue or a color to distinguish between them. But let's say we want to mix two different variables, like for example uh, P pH or residual sugar. Yeah, you can take any two of them. So if we use a scatter plot, obviously when you will create a scatter plot between these two variables, so it will give you their relationship. So let's say we are putting pH level on x-axis and residual sugar on y. So this is kind of a correlation between these two variables. If we don't summarize them, so it will be output like this. So pH is on x-axis, residual sugar is on y, and you can see uh, there is only one such case where pH is 3.39 and residual sugar is between the average range, or we can say pH is actually in the average range and residual sugar is 65.83. And here what we can do, uh, in legend here, okay, legend or size, we can bring the quality to see quality's effect. If you will bring in size, you will see these scatter points of different size in different ranges. So that is also something that we can do, but we can also bring quality in legend here, okay, because we have 9 different type of values, and here you can see for quality 9, if you want to see, you can see where are those points, right? For quality 7 also, you can see where are those points. So for what combination of pH and residual sugar, what quality you are getting, you can see that, right? And here we can also remove, let's say we don't want to use pH here, we want to use sulfates here. So see the effect of sulfates. So here you will get a different type of graph, and you can see when sum of sulfates and residual sugar. So first we have to make it unsummarized as well. Now this will be proper value. So here you can see, let's assume quality 9. So most of the quality 9 values are between this particular circle here, right? Where you can see the residual sugar is also, residual sugar range is there, but sulfate value range is between 0.36 and 0.71. So this is also one way of visualizing the effect of different variables. So we can also simply copy this and put it here. And in size, you have to use any other numerical value because size is also a numerical thing. So this is one way of analyzing, and here also you can see different filters are working. So for white wine, you can see range of sulfates is more. For red wine, you can see the range starts point around 0.33 for sulfate and goes up to 2.9. So you can see for different type of wines here, and this way you can visualize two different variables versus your target variable. Now similarly, as we created these two charts here, so these are simple clustered column charts. We have also created another cluster of chart with creating groups for pH. Here the only thing that we have done is we have created 5 bins here, not 12. That's why you are seeing different values of pH, because we can see in case of pH value, the variance between the minimum and maximum value is very limited. It is starting with 2.72 and ending at 4.01. So we have all the samples between that range. And when you will visualize it, let's say we want to see for white only. So here you can see for increase in pH values, initially we do have some increase in average quality of wine, and obviously when it is increased beyond a certain point, it starts decreasing. So the perfect value for is 3.24. There, that's where we have achieved highest quality of white wine. Similarly, in case of red wine, highest value is at pH value of 3.75. So this way you can simply visualize the data of different type of wines here, right? And similarly, we will use something for volatile acidity, total sulfur dioxide also. For sulfur dioxide, we will use, let's say, 8 bins, because in less number of bins we can, you know, do the analysis more easily. So we have created group here. We will simply copy this, and here we will remove pH bins and bring total sulfur dioxide bins here, and this will tell you a simple story, like in case of red wine, highest quality achieved when total sulfur dioxide value is around 277.25, and this is average quality by SO2. So average quality by SO2, Similarly, we will copy this and use another physicochemical property, and we can actually put more values here, but we have seen that most of these variables do have some effect on the quality of wine, so we'll simply use them. And here we will simply use for sulfates also. Obviously it is repetitive now, but that's how you can see effect of different type of variables on your output variable. If it is numerical, then it becomes easier. You can use a scatter plot or clustered column or clustered bar chart. Here we will simply bring the sulfates bin, and in this case also you can see different sulfates value that are affecting the quality of wine. In case of red wine, high qualities are, in case of white wine, high qualities are achieved at around sulfate bin of 0.81. So this way you can see, as per the quality value, you can pick from different variables what is the best range for different type of wines, and this is by sulfates. Next, using Python, when we will create machine learning model for prediction, then all these variables will be helpful for creating the model and predicting the value. How it will work is, in order to predict quality of a wine, you will provide different parameters, and like you are creating something, so you will say, okay, we have this much value for sulfate, this much percentage of alcohol, etc., and on the basis of this a quality can be predicted. So this is a simple analysis, and obviously if you want to see more variables, you can create different charts here, and this is a simple wine quality dashboard that we have created, showing effect of different type of physiochemical properties, physiochemical values on wine quality value. So I hope you like this tutorial, and if you want to see when we will create simple machine learning models to predict this, then please subscribe to our channel so that you will receive a notification whenever we'll upload that kind of video. Thanks for watching. Have a nice day.